This is going to be more than a week's worth of work, and actually I'm considering going to 2-week updates. I'm not sure, but either way, because of vacation, a recent vacation, this is actually like a week and a little more of work. So I completed all of chapter 6 reading, and I don't remember last time, but I think last time I had finished reading chapter 5. So I read all of chapter 6, which went pretty well. Residue theory. Of course, I keep marking these. I'm not sure that this page means anything anymore. And then I did some problems in chapter 5. Yeah, chapter 5, because of series, is kind of a slog, but I'm having fun. It's fine. Then in the book, I've been working on the major thing that I did the last couple of days was Lawrence series, and I'll show the work. But yeah, I've been working through some of these problems in the mid sections of chapter 5, and they take a while, which is good. I enjoy doing problems, and I think it's really important to do problems. And so then I've begun thinking about, and we'll start working on zeros and singularities, section 5.6 problems soon. Then for reading, of course, I've completed chapter 6, so I am at the gates of chapter 7, all about residue theory. Now in the case of chapter 5, going back to chapter 5, it's got a lot of important material. It's got analytic continuation as the last section. It also has, there you go, analytic continuation. It also has the point at infinity, zeros and singularities, and series. These are all really important sections in my view, and so I see no issue with taking a really long time to go through chapter 5 problems, very similar to what I did with Wade for the series chapter, the chapter that had Taylor and Power series. I really took my time with that chapter. I think I even took like a whole month to read it. Last time I showed the notebooks, last time I showed the notebooks, I don't think I'd call this book complete, and since then I did some more chapter 4 problems, so I completed chapter 4. This is my little marker for what I talked about last time, and I did reasonably well, chapter 4 problems. Although, in this case I thought, I knew it was mn factorial in my mind, but then I said, I changed it at the last minute. So that happens sometimes. Just worked on some more problems. And then I found this very nice list for I think it's a graduate level course that has all these problems. They're not solved, but it's a good way to think about harmonic analysis. So the harmonic series. There's a lot of Laplace equation sneaked into Saff and Snider, and I think that's a topic that I want to go into at some point. And so I kept this for future reference, not to do anything with right now. Then for the rest of the work, I was not done reading chapter 5 the last time that I showed my progress. And of course, ever since I have completed chapter 5 reading, there's an analytic continuation. I hadn't read about that before I left for my trip. Schwarz reflection principle from one of the problems. I want to read about the Schwarz reflection principle a little more. Then working on chapter 5 problems. Mixed bag of getting things right and wrong, but I get some things right, and that encourages me in my learning. Of course, self-teaching, as I often mention. Shadowboxing, I'd like to take courses at some point. This year it's not going to work out for various reasons, which allows me to do more shadowboxing, and that's fine. But I'm looking forward, maybe next year, the year after, I don't really know, start taking courses again. In the case of working out these series, the closed version, I did not work on them. Instead, I did the terms, and the terms were correct, but I just didn't figure out how to come up with the general series. This is something that I need to come back to. I definitely did not get that right, but I understand what I need to do. I did many of the low terms, and then problem 10, which was proving the Leibniz formula for the derivative of the product of two functions. I worked on it, and I was like, I'm not getting it. It was not a simple induction proof where you do the n plus 1 term, and then you can subtract out the n term, and then you get a little term that fits the equation. That's not what's happening here, because when you do derivatives, and I did an example before I finally realized what I had to do, I did an example, and I realized the equation, because of the way the derivatives work, is always different as you make higher level derivatives. Because the total sum of the derivative factors for f and g is that number. It's either n or n plus 1, L plus 1. And so really, this is where I finally figured it out. I wrote out a few terms, and then I figured that you combine them. And so I didn't clean it up, but I know that this is the correct proof. You write out fg to the jth derivative, then you differentiate that. Then you compact the terms, you group the like terms, and then when you group this together, what you get is fg to the j plus 1, and that's your proof. So I got that right. Then I started doing better. Came close here, but I think I made an arithmetic mistake. I got this one right. Didn't get these right, but got these right. And then this, I was on a roll here, so I got all these right, all of them. These two, you multiply two series, and when you get all the terms, the only term that's not 0 is the 1 over z term. If there is no 1 over z term, which there aren't in this product and this product, the integral gives you 0. So it does not satisfy the 1 over z minus 0, z minus z0, dz is equal to 2 pi I. So I got that right. I was like, man, is that a trick question? It wasn't. Then this one I got right as well, where you do the derivative of the series. And, oh, where is it? No, I'm sorry, that's the wrong one. Never mind. More questions that I got right. A few wrong, a few right. I gotta go back to these. Yeah, got these right as well, most of them. This one, for the Lorentz series, I just stopped and I said, okay, I need to understand Lorentz series. The book actually does not do a good job, I believe. So if I go to the Lorentz series part, see, it's section 5.5, I believe. Section 5.5. The examples are good. By the way, this example right here is also worked out in Churchill, but with a negative sign. The function is -1 over z minus 1 times z minus 2. The way this is worked out, it's not entirely obvious. Even though after you read it, you know what you're doing. You know you're going to get the 1 over z terms for the right and the z, so positive powers to the left of the interval, a mixture in the middle interval, and then the right interval where the numbers get large. You only have convergence for the z to the negative j powers. That's true, but this is not explained well. Churchill explained it a little better, showed the 2 over z terms, how they flip, 1 over z, 2 over z, and then z over 2 in the lower. But then I found some great handouts. This is a handout for another problem, for z to the 1/2. A little Russian, I'm sorry, not Russian, Riemann surface. What am I saying? Then I did find some great handouts for Lorentz series, and took some notes, learned from the examples. This particular one, MAB 241 complex variables, whatever that course may be, this was perfect. Nailed it, because it explains 1 over 1 minus z for the unit circle less than 1 is z to the n. for the unit circle greater than 1 is -1 over z to the n. And once you have that pattern, you just take all your terms and you put them through that, and then you look through your interval, and depending on the interval is which term from which factor goes in. And so yeah, that worked out pretty well. I got yet another handout that I didn't use, but it's good. It's got more examples worked out, and it's got other topics that I know I'm going to use later. And so yeah, sure, once I turned to working on the Lorentz series examples, I started doing better. And so have I graded these? Yeah, here we go. So this is an example where I got it right. I mean, I came very close. When I look in the back of the book, my terms are off very little. And I think, yeah, I was close. I was close. So there's my progress for the last 2 weeks roughly.